All right, guys, welcome back to the second part of 5.6. And today we are really just going to be going through some examples. And so, first one is a word problem. A baseball fan is sitting directly behind home plate in the last row of the upper deck of the U.S. Cellular Field in Chicago. The angle of depression to home plate is 29 degrees and 54 minutes. So I'm already thinking there's a guy up here watching the game. An angle of depression means if he's looking here, that's a horrible straight line. If he's looking straight out, then the angle of depression is downwards, right? This would be the angle of depression. And it said that is to home plate, so maybe I'm going to draw just a little plate right there, a little home plate is 29 degrees and 54 minutes. And I'm just going to immediately write this triangle here. These two angles are going to be the same, and 29 degrees and 54 minutes is actually 29.9 degrees, so I'm just going to write that in right away. And the angle of depression to the pitcher's mound is when the pitcher's mound is going to be even further out, right? So now I'm going to get rid of this. The pitcher's mound is going to be even further out, right? Because he's behind home plate. And so now maybe that's the pitcher's mound. And the angle of depression, so again, the angle of depression is this, which is going to be, I should do two ticks since it'll be different. It's going to be the same as this angle, right? And that's 24 degrees and 12 minutes, or I'm just going to convert that right away, and that's going to be 24.2 degrees. In Major League Baseball, the distance between the home plate and the pitcher's mound is 60.5 feet. How far is the fan from home plate? So pitcher's mound and home plate is 60.5 right here. And I should honestly probably draw my home plate a little more out of the way. So where's home plate? But there it is. And what are we looking for? Let's say what we're looking for. How far is the fan from home plate? So it's looking for this distance. I'll call it D for distance. The distance from home plate to the guy. And, we're in the section law of sines, so it kind of makes sense to use law of sines. It also makes sense because this right here really isn't a right angle at all. So let's, work with this and see what we can do. Well, we know that we want to involve this D. And so let's just write that. We have D, and then the law of sines will say over the sine of 24.2 degrees. And now the only other piece of information we have is this 60.5. So let's use that. But then over the angle, over this angle, right here. And how are we going to find that angle? Well, we know this is a right angle. So then the remaining angle up there has to be 180 minus 90 minus 29.9. And that'll get us 60.1 right here. And we know that up here, we know this is 24.2 degrees. And we know that this is a total of 90 degrees. So if we do 90 minus 60.1 minus 24.2, we're going to get that this is a measly 5.7 degrees. And so now we can finish our law of sines to sine of 5.7 degrees. And now we just solve d equals, multiply that sine of 24.2 degrees over. And I forgot my 0.5 right here. 60.5 divided by sine of 5.7 degrees. And when we do that, we get 249.7. And then this will be in feet. And so the trick to these word problems really is, again, always draw yourself a picture. And then once you draw yourself that picture, just kind of work with what you know until you find things I need, right? So I was like, well, we don't have a right triangle, so we're probably going to use law of sines. I know I'm going to want to find that D. So I said, let me put this D in right here. And then we knew the angle corresponding with it, so we could put that underneath. And then I said, hey, this 60.5 is given to us. We should probably use that. And then I said, well, that angle is missing. How can I find that angle? And so it's kind of, math is kind of just about asking yourself the right questions, right? And so I was like, well, how can I get that angle? And then I realized I knew this one, the 24.2 at the top. I knew that one from the angle of depression, part of the problem. And I knew I could figure out this 60.1, which, the only thing remaining would be the 5.7. So again, it's just about asking the right questions when you're doing problems. And hey, look at all this stupid garbage for finding the area of a triangle. Your book gives you these formulas with K as the area of a triangle to find the area of a triangle. Who in their right mind wants to memorize that? Not me. So you can look in your book and you can pause this video and write it down if you truly wish. But I think it's better to just think about it. And so, for example, 3, it says, find the area of triangle ABC if A equals 4.7, C equals 12.4, and B equals 47 degrees and 20 minutes. And again, I'm just going to sketch this, right? B is 47 degrees. That's about half of 90. And the rest, who really cares what the rest looks like? Because I sure don't. We have this angle, let's call this one B because that's the one we made, is 47, and then 20 degrees is going to be 0.3 repeating degrees because 20 divided by 60. And then across would be B. And then it doesn't really matter where the others go. If we said A goes here, then A is there. And if we said big angle C is there, then little c is there. And it doesn't matter if it's not proportional. You just have to know what you're doing, right? So A would be 4.7. And C would be 12.4. And now it is a law of sines problem, but notice it's asking for the area. So to find the area, we would need the height right here. Well, now this gets weird because we don't know, we have 12.4, but we don't know exactly how much it is. So let's find this height h. Well, I bet to find that height h, we can use some trigonometry. So let's involve this angle B and two sides that we know. This 12.4 gets messed up because we've kind of cut it up with this altitude. So let's use this angle here. We need to involve h, our height, and our hypotenuse. So what does that? That'll be sine of 47.3 degrees, 3 repeating degrees, and that is going to equal opposite, which in this case is our height, over hypotenuse, which is 4.7 in this case, because we've made a right angle here. And this is where you can definitely tell our triangle is not to scale, but that's why it's important to know where your right angle is. And then we have 4.7 times the sine of 47.3 repeating degrees equals h. And so if we just stick that into our calculator, we have 4.7 times the sine of 47.3 degrees, and we are left with 3.45 about. Well, and now we have our height, right? And what's the area of a triangle? Is A equals 1/2 base, which would be 12.4, times the height, which is 3.45. We just found it. A is a bad name because we already have A, the angle, so let me call it capital K. And once we do the calculator, we get 21.39, and then it would be whatever units it is squared. And that's how you want to tackle these type of problems, right? So my advice is don't use all this garbage. Just think about how you would get the area using trig. And let's go over one more example. I know this video is going to run a little long, but find the area of triangle DEF if D equals 13.9, and angle D equals 34 degrees. So we have angle D is 34-ish. E is really small. E is like that. So let's just go with that. So if I said that's D and that's E, then this has to be F. Across from D is going to be 13.9, and we have 14.8 degrees there and 34.4 degrees. And again, I might actually write this outside. We have 34.4 degrees there. And then I'm just going to call these E and F. And again, I'm going to draw an altitude there because we're going to need to know the height. Now, this one is a little trickier because we have some more moving parts. But essentially what we need is we need this height and we need this entire base here. And so to find the height, there's not really things we can use that are too helpful to us right away, right? So we know the angle D, but we don't know much else about this triangle. Oh, but if we look at angle E, we could use that, right? We have two triangles to work with. And so after looking at E, I see how we can get this height, right? So if we use sine, and then I'm looking at angle E of 14.8 degrees, then that is opposite, which is h over hypotenuse, which is 13.9. Multiply that over and we get h equals 13.9 times the sine of 14.8 degrees. And when you plug that into a calculator, we're going to get the height is about 3.55. And now at this point, we just need the length of, we need F, right? We need the whole bottom length. And so I'm going to do F. I'm going to use my law of sines here. We can get that angle, right? The sine And then the angle of F is just going to be 180 minus 34.4 minus 14.8, which is 130.8 degrees. And then let's just use two more sides we know. And then it's given 13.9 to us, so that's a nice one to use. And that'll be all over the sine of D, which is 34.4. And then solving for F, we get F equals 13.9 times the sine of 130.8 degrees, all over the sine of 34.4 degrees. And if we throw that into our calculator, I'm getting 18.62. And at this point, we just know that the area, A is not taken this time, so A for area is 1/2 base times height, but in this case, our base is F, which is 18.62 times, and then our height was, what was our height? 3.55. Which is going to be 33.06 and then units squared. And again, I just recommend drawing that altitude down and then using the trig that you know combined with the law of sines to get what you need. And really what you need for an area is a base and a height. And that's all we did. We're just following logic rather than following some stupid memorized dumb formula, right? I think it's much easier to logically work through these than it is to memorize 6 dumb formulas. But that is going to wrap it up for 5.6. I know this lesson was a little long. Sorry about that. But this is really important, being able to work through these. So I think it was a worthwhile